Okay, so that's a tough question. Okay, all right. Indicate where these intervals are. All right, so I got 2x cubed, okay, minus 3x squared, minus 12x plus 20. Okay, all right, so I'm going to zoom out so I can see this better. Okay, so I got this kind of graph. All right, that's negative, negative, positive, positive. Okay, and then I'm at negative 127, and then I'm at 2, 0. So they want increasing only. So I start on the left. This would be an increase, decrease, increase. So I'm going from negative infinity to negative 1. That would be one of them. From 2 to infinity would be the other. Okay, which of the following values has a relative minimum on the interval from negative 3 to 6? So what they're talking about is what is the apparent relative minimum? Okay, the relative minimum would be this one. Okay, all right, which would be 3, negative 4. Okay, so my value there would be negative 4. Okay, which intervals is this increasing? Very similar to this other one. Okay, I would put in negative x cubed, okay, plus 2x squared, plus 4x minus 2. Okay, once again, I'd zoom in so I could see a little bit better, but this is what I have. Okay, all right, so it wants to know which interval is it increasing through. Did I type that right? Negative x cubed plus squared plus 4x minus 2. Okay, so I guess they want to know, well, where is this increasing? Okay, well, we know it's not increasing from 2 to infinity. Okay, we know that one's no good. From negative infinity to negative 3. Okay, all right, that one's no good. Okay, from 0 to 2. Well, 0's here, 2's there, so that would be what I would say would be that. Okay, what is the 0 for 9x minus 243? You can do this a couple different ways. If you want to do zeros, you can always just figure out where does it cross at. That would be 2.5. Okay, if you wanted to solve that, okay, this is 9x minus 243. 243 equals 9x. This would be a log question, so log of 9, 243 equals x. So another way to do that is log of 243 divided by the log of 9. I think it's probably easier just to graph it and find where it intersects. 2.5 is the answer. Okay, the graph has, what do we want from that? Okay, that would have x plus 1 divided by x. So that has, so if you wanted to know if it had an x-intercept, if you solve that, the top part, it would be x equals negative 1. To get the y-intercept, put 0 in for x. The problem is, if I do that, that would create, for the y-intercept, if I put 0 in for x, that'd be 1 over 0, which means it can't have 1. So it's got one x-intercept, okay? Let's go on to the next one. This video is getting a little long, okay? All right, describe the end behavior. What that means is you have to look at the horizontal asymptote. Well, what scenario do you have? The numerator has a bigger, is bigger. So what does that mean? The horizontal asymptote would be y equals 0. So that's what the end behavior is. Okay, all right. Okay, as x approaches negative infinity, y would approach 0. So that's how you figure that out. Okay, all right. Describe the end behavior of this graph. So once again, I like to, if I'm going to give the option to be able to graph things, I want to be able to look at them and then be able to figure it out. Log 2 divided by, click over here for x, and close it, plus 5, okay? And I know that if I solve the inside, 2/5 x equals 0, all right, I got a vertical asymptote at 0. Okay, and the graph is doing this. So it says, describe the end behavior as x approaches 0, because this would be 0, negative infinity. This is positive, positive. X would approach negative infinity. Okay, the next question says, drag the answers. The vertical asymptote, you solve that, that's x equals 3. The scenario I have here is tie, so I do 4 divided by 1, so that's y equals 4. So I write y equals 4 here, okay? Which of the following is an inverse? So that's y equals x cubed minus 8. This is x equals y cubed minus 8. Add 8. That's x plus 8 equals y cubed. Take the cube root. So that would be this one. Okay? And so if I don't mess this up this time, I'm going to start with this function. All right? I'm going to put in h. I input that function. And they want to know what's 12, so I would put 12 here. Okay? So I would just do 2 parentheses. 12 divided by 3 is 4, so 4 minus 7 squared minus 5. And that would be 13. I really have 16 pages? Man. Okay, which function represents f of g of x? So I would start with this function. I would put in this function. Okay, and what you can do, since it's a graph, I could just graph that. Hit home. It crosses here and here, 3 and 1.5. Which that would be, for me, would be this graph, graph A. But that's how I would do that. I would start with that f function, and I would put that in there. Okay? Select the zeros. Well, remember, these are opposite signs. So x plus 1, this would be x plus 2/3. This would be x minus 5. Now, we don't usually see this, so we move that 3 up there. So it would be 3x plus 2. X plus 1, 3x plus 2, x minus 5. Some of these are really easy. Some of them take a little bit more work. Okay? What's the model? The best model is x of y. This is a distractor, so you don't really want to put that in there. So I go table, okay, 25, 35, 55, 125. Then I got 2100, 2800, 5060, and 40,325. Okay? Now, if you look at my possibilities of answers, sometimes it dead gives it away. So in this case, it's either a linear or an exponential. I'm going to try the exponential. Y1. Curvy thing there, A, parentheses, B, exponent, x1, okay? And the r squared is 1, which is good, so 993, 1.03, that's going to be my best example, okay? All right? Moving on, 36, okay, all right. It says volume varies jointly with the square of the radius and the height. So that's what I would do for joint variation. The container has a height of 10, volume 377, radius of 6. I'm finding K, okay? So I would have 6 squared times 10 would give me 360, so 377 equals K 360, divide by 360. I got K equals 377 divided by 360, which is 1.047, or just gonna stay that, I guess. Then it says, so then I rewrite my equation. It says, what is the volume if the container is 4 centimeters high and has a radius of 4? So I go 4 squared times 4. So this, right, 377 divided by 360. Times r squared, which is 4, times 4. Okay, so that would be 3,016 over 45. Okay, all right, it says select all that corresponds below. What do I have left?
Good afternoon, students in the building. At this time, you should be with a teacher or a coach or a sponsor. If you're waiting for a ride, please make your way to the boat. You should not be in the commons, commons 1, commons 2, or the hallways. Thank you.
Okay, it says, oh, I forgot to go back. I forgot to do this one. Oh, this is a lot longer than I thought it would be. Okay, all right, it says, select all the ones that apply. The normally distributed data falls for 32 cities as summarized in the histogram. The mean amount is 32.5. Standard deviation is 4 in the histogram. All right, plot out 1.5 standard deviations, okay? So what that means is if the standard deviation is 4, 32.5 would be obviously in the middle, okay? The standard deviation is 4, 1.5 standard deviations would mean 6 this way. So what you would do is you would click this one, and then, because 32.5 plus 6 is about 38.5. 32.5 minus 6 is about 26.5. So I would click this one, this one, this one, this one, this one, and this one. Oh, oops, not that one. Because I want to go up to, I would want to go up to that one. So I would want to click all these, okay? Because that would represent 1.5 standard deviations each way. Okay, the heights of 200 kindergartens at TE Elementary are normally distributed with a mean of 40 and a standard deviation of 40.5. So I got functions. I'm going to go down and find that NCD, the normal dist function. Okay, mean of 40, standard deviation of 1.8. I want to find the probability. Okay, it's between 37.3 and 44.5. So that's my probability, 0.9269. Now it says there's 200 people, so I got to multiply by 200. So 0.969 times 200, okay? And round to the nearest whole number, that's going to be 185. Okay, a normally distributed set has that. What is the closest? So what I'm going to do is I'm going to change this. I'll go back and we'll start over. It's faster. Dist, okay. Mean of 108, standard deviation of 11. So I'd have 108, comma 11. And then they want above 125. So if I made this curve 125, this would be positive infinity. I want above. So I want to do cumulative. I'm going to put the minimum as 125. Okay, that's 0.061. If 0.0611 times 968. That's going to be 59. Okay, so let's see where that could be. Yep, that would be that one. All right. Okay, so the amount of money raised, the mean for the class. So what you have to have an idea of is Z equals the item minus the mean divided by the standard deviation, okay? All right, so Jill, okay, all right, says which of the following raised the greatest amount of money, okay? So Jill would be 1.8 equals X minus 60 over 11, okay? So I would cross multiply that up. So that's 11 times 1.8, okay? And then I would add 60 to that. So Jill is 79.8. Then Cal is 2.1 equals X minus 58 over 12. So same deal, cross multiply that up. 2.1 times 12, and then I would add 58. That's 83.2, okay? Then Monroe would be 1.4 X minus 55 over 13. Cross multiply that up. 1.4 times 13, and then add 55. Oops. That'd be 73.2. And then Tim would be 2.5 equals X minus 57 over 10. Cross multiply that up, that's 25. And then I would add 57. That's going to be 82. So in this case, it's Cal. Okay. I think this is the last one. Okay, long video. Okay, type your answers in the box. A data set is normally distributed with a mean of 68.42, a standard deviation of 7.91, and an element set is 57. What is the z-score, all right, for that? All right, well, z equals, the item element is 57, minus the mean, which is 6842, divided by 7.91. So that's just a simple calculation. 57 minus 68.42. Okay, take that negative 11.42 and divide it by 7.91. And that's negative 1.44. Okay, all right. Moving on to the next one. Okay, the graph summarizes 50,000 students. Okay, the data set is normally distributed with a mean of 81 and a standard deviation of 2.5. Identify the regions under the curve where the data, only the data approximately for 230,000 students is located. So what the idea is this is one standard deviation, two standard deviations, three in the negative. All right, this is one, this is two, this is three. So what you have to do is have an idea of, like, you take out the dist, the norm dist, okay, all right, they have mean of 81, standard deviation 2.5, okay, and the idea is, okay, all right, region 1 would be from 81 to 83.5, okay, so that's 0.3413. Which means this is 0.3413, okay? All right? From 81 to 86, all right? Or you could just do, you could do 83.5 to 86. That's 0.1359. So that's going to be 0.1359. If you wanted to do 86 to 88.5, that's 0.0241. Okay, and then you can multiply all of those numbers by 50,000. So this is 1,070 right here. Okay, 0.1359 times 50,000. That's 6950 here. And then 0.3413 times 50,000 is 17,065. And that's the same thing mirrored over here. It's really looking sloppy. Sorry. Let me put this out somewhere out here. Can't even read that. Sorry. Can't read this. So that's 1,070 here. That's 6,950 here. That's 17,605 here. And that's the same thing. So it asks for, how would you get to 23,000? Okay, well, if you added two of those together, that's too many, okay? So you just have to play around with the numbers till you would get what you were looking for. So you got 6950 plus 6950. Well, that's the problem here. That should be a 5. Oh man. 695. 6795. So we're trying to get 6795 plus 17,605. It's too many, okay? All right, but that's what I think you do. You can pick 5 and 6. Okay, store owners, okay, all right. An employee has a total of 3 cashiers, 7 clerks, or committee of 1 cashier, 2 clerks. So that's a 3 choose 1 times a 7 choose 2. Okay, so you use where is it? Oh, there it is. Okay, so 3 choose 1 is 3 times 7 choose 2. 21, multiply that, you get 63. Okay. This is a permutation because you have titles. Okay. All right, so this would be an 8P3. Okay, president, treasurer, historian. Okay, so I just use the same. Okay, I would do, let me get rid of that. 8P3, it's 336. I think that's it. Yes, that is a long video. Let's see if I can split it in 2 25-minute increments from here.